Welcome, everyone. I'm Searle Amin, and I work for ARM. I want to welcome you to the Transformational Power of Confidential Computing panel. I work closely with our customers to realize future ARM architectures on their silicon, and I'm a fervent defender of my own personal data, so I find our topic today especially interesting. I'd like to start off by having everyone introduce themselves. So we have Dave Kleidermacher from Google. Why don't you go ahead?
Hi, Searle. Yeah, my name's Dave Kleidermacher. I lead the engineering team for security and privacy at Google, working on connected devices, which includes both Android as well as our Made by Google products.
Peter Armstrong.
Hi, everyone. Peter Armstrong. I work at Munich Re. I'm the chief cyber SME at Munich Re Group. Munich Re is the largest reinsurer of cyber in the world. I have a defense and intelligence background, so I'm a cyber geek. I am also an ERM specialist, and I work with Munich's very largest enterprise clients.
We have Ron Martino from NXP. If you could introduce yourself.
Sure. It's a pleasure to be with everyone. I'm at NXP Semiconductors. I'm the Senior Vice President and General Manager of the Edge Processing business. I've been involved in the industry for 33 years, working on embedded compute, and so I'll represent the edge devices in the world of edge to cloud computing in the talk today.
Up next, we've got Mike Bursell from Red Hat.
Hi, my name is Mike Bursell. I am Chief Security Architect within the Office of the CTO at Red Hat. I'm a member of the Confidential Computing Consortium. I'm the treasurer there, and both a TAC technical member and on the governing board as well. And I'm a co-founder of the NARCS project, which is an open source project around confidential computing.
And finally, we've got Richard Searle, who comes to us from Fortanix.
Yeah, hi, Searle. My name's Richard Searle. I'm the Customer Solutions Director at Fortanix, Inc. We're a leading vendor of confidential computing solutions based in Mountain View in California. And I'm also the Serving General Members Representative to the Linux Foundation's Confidential Computing Consortium. So it's a pleasure to be part of the panel today.
Thanks, everybody. Confidential computing, I mean, we are all very familiar with it, but what I wanted to start off with was what you think about the industry and enterprise space especially. What do you think their understanding is of the concept of confidential compute? Is it widely known, or is it really just in our space, those of us who are working on it, who are working within the Confidential Compute Consortium? Mike, let's start with you.
Yeah, sure. I think it's getting there. I think people are realizing that it matters. And just to give a definition, confidential computing is about protecting your applications, your workloads from a host which is compromised or malicious or from external attackers. So keeping your workloads safe using hardware controls. That's how we kind of think about confidential computing. And I think people have begun to realize that there are some workloads they're not happy about putting on the cloud, or which are not safe on the edge, maybe because boxes aren't physically secure. So it's a growing thing. I think there's growing knowledge of it. And the Confidential Computing Consortium, which Richard and I are members of, is aiming to raise that visibility. But it's in certain sectors. Richard, I don't know, do you take the same view?
Yeah, thanks, Mike. As Mike said, the Linux Foundation's Confidential Computing Consortium has brought together leading players within the industry. And what we've tried to do is define the term around the use of trusted execution environments based on hardware. But people are still conflating that technology with just a general envelope of protection around your data and applications. So whilst the consortium and also the industry participants have been undertaking a program of market education in the past 18 months since the consortium was founded, there's still some confusion about exactly what this new technology is, what capabilities it brings. And I think, panel sessions like today and the events that the consortium and the industry players are attending to promote this message are important in defining the position where the confidential computing sits within the data security landscape. So that there's still work to be done. It's a new market, but events like this help to get the message out about what this new technology can bring to data and application security.
I think confidential computing is, for many people, is sort of it's synonymous with cloud compute, like it's aspects of cloud computing, and people don't think of it as applying to phones and IoT, and that's a mistake, because it like the same challenges that confidential computing is trying to solve in the cloud are just as important across the gamut of products. And so that's one of the problems why there's not, I think, sufficient awareness, is that realization of the importance there. I think the other thing that feels to me like a barrier to awareness is the technical jargon that happens. Like when you read about confidential computing, it does jump right into trusted execution environments and blind hypervisors and memory encryption. These are all, dare I say, fun topics.
Peter, since you come from the insurance aspect, more of the ecosystem side, I'm really interested in hearing how much awareness there is within the larger developer community about confidential computing, because it's really about all of these data on these devices that those developers want to make use of, and certainly in the insurance industry.
Sure. So I mentioned at the top that I engage with some of our very largest enterprise clients, and in anticipation of the session, in meetings within the last 10 days with two of the world's biggest energy outfits, I raised the simple question: what do you understand in the context of confidential computing and what it means in relation to the initiatives that you have underway, particularly when we reflect on some of the challenges that they face. They're being bombarded around how to reflect upon networking, the security of networking, the evolution towards SASE, recognizing that there's going to be a bunch of stuff going off on the edge that they want to take advantage of, but have got no clue how to start to architect this. And I think it's at a real fundamental level, and that is that there isn't a real understanding of the opportunity and where this resides as a component in a broader capability value chain.
If I could add to what Peter said, because you mentioned edge multiple times, which is a focus area. As an industry, and many of the different applications and companies that I'm working with to build that infrastructure, they're all focused on how do you deploy these many devices that are generating data, processing it, and working complementary with cloud or data center computing. And it's all about securing against many different attack scenarios from a security perspective. This includes both the data, the software IP, dealing with multiple entities, some trusted, some that aren't trusted. And it also includes ensuring security against physical and remote attacks. So when you think about this whole computing concept and deploying devices, it's this edge to cloud computing concept that is applying confidential computing, but also edge processing computing. It has a significant security aspect to it in terms of how you enable these devices, and then the interaction between these devices, an aggregation point, and a cloud working complementary and between each other.
Can I just reflect on something? A couple of things actually. Firstly, Ron, I think you're quite right. It's a combination of all these things, and you mentioned a really important thing about IP. It's not just data that you're protecting; it's actually the applications themselves. And it may not be your data; it may be your customers' data. These are really important things, and you're quite right to do it. And the thing, Peter, that you said is it sounds really complicated. I think at the moment it is. These are immature technologies. The software is coming out. People like Fortanix, Richard and other companies and other projects trying to find ways to get this so it's easier to adopt.
One of the use cases for confidential computing in the cloud is anti-fraud. And if you think about an example, like in confidential computing, imagine I have a user, they're on an Android device, they're using Google Pay to do some sort of transaction payment with a retailer, and there's of course a bank, a credit card company and bank behind that as well. If you think about that, all of the subjects in that chain have a lot of signals and intelligence that help detect and prevent fraud. So my Android device sees the behavior of the user and the apps on the device. The retailer obviously sees the web activity on the website. Google Pay has the information about the payment history and payment credentials and things like that. The bank, of course, banks have a very rich set of signals, but they're all stovepiped, right? They're all in their own domains. And with confidential computing, we can now take all of those and find smart ways to share that information in a privacy-preserving way to really do a good job and do a better job of that than we have in the past.
Yeah, and there's certainly, I think, a real hardware aspect to it. So I want to come back to Ron, because you definitely have this breadth of customers, and it's very much hardware focused. So what can we do as an industry to incentivize the device manufacturers for Edge, for mobile, for PCs to implement the hardware, which is costly, in those devices to enable confidential computing?
Yeah, no, it's an interesting point, and I mean, our focus is to make it less costly. The whole idea of hardware and software security and transit of data between different devices at the edge or between edge to cloud becomes very important. What we're doing on the hardware side, and we recently announced, is the integration of secure enclaves within the processor itself to create a secure environment, and then building around that years of experience in financial communities and transactions and banking industries and governments that we've developed to really create both integrated capability and discrete capabilities that can enable these many devices that work and interact with the clouds. You need to control all of the system dynamics in a secure way, and it's not just protecting data and software. Which is a part of it. It's protecting the integrity of the system, because as these systems become more intelligent between cloud and edge, they're going to be making decisions independent of us, and you don't want someone to influence the decision making or the action that these end devices make when you combine the compute capability that we're translating to real world applications that are meaningful in our life.
When you think about the promise of confidential computing, what is it that you use as the example to explain the vision? So, Richard, for you, when you talk to customers, what do you try to convey to them as the vision of confidential computing?
So there's two ways that confidential computing can be applied here. The first is to enable new business models and new services over that data that can now be secured in use in order to monetize those data assets. And secondly, as we've seen with some of the projects, particularly within the work that we're doing with public agencies, increasingly what confidential computing can offer is a level of control over the data that these businesses can offer to their customers. And in fact, we've seen in Germany, as a particular case in point, changes to legislation that have required the adoption of electronic health records for use with health insurance companies. And that particular project is providing control over that data and access to the data at the patient level, whilst also ensuring that the system architecture as a whole can be approved by the regulatory agencies. And so what confidential computing is enabling is extensions of existing business services into environments where, because the ability to protect that data in use, particularly using cloud services, hasn't been available, you're now able to adopt additional services to integrate with third-party operations. We're seeing an extraordinary growth in interest in the adoption of machine learning and AI within confidential computing to provide those kinds of services. And this is the promise of the the technology.
It's very exciting, but at the end of the day, I think what's really key for this is this intelligence paradox. What this enables is us to break through what otherwise seems like this very difficult world we're living in where systems can't speak to each other, they can't share information, and confidential computing, private computing breaks it is an intelligence paradox. It says that actually we can share information in a very powerful and seamless way while still retaining absolute data ownership. That's data exclusive control of the data. That's very exciting.
The promise, well, the hopeful promise, I think, of confidential computing is for us to be able to say, here are the entities, the people, the chips that I trust. And these are the ones I don't. And these are the ones that I care about making as secure as possible. And I think once we can list those and be clear about what those trust relationships are, and I've got a book coming out later in the year about exactly this, then people like Peter and his industry can say, yeah, okay, if these are the ones you're trusting and these are the ones you're not trusting, then we can underwrite you. Then the auditors can go. That's where I want to be.
People are scared of being exposed, of not having enough knowledge. And so there is an emotional barrier that many that we need to persuade and educate to be prepared to have the conversation. We are going to have to represent it. We are going to have to represent it with some imperatives. And I think the insurance industry, the reinsurance industry, has a significant role to play because, as you say, Mike, if we can't get insight as to the exposure in these value chains, we won't underwrite them.
Yeah, no, if I can add to the impact to society. We've touched on healthcare, and I completely agree. There's some significant impacts on just general safety, leveraging medical, as well as how you interact with the world around you when you consider the pandemic that we're living with and how do you interact with things and people in a way that is safer. It also applies to the productivity of society. Businesses can become much more productive. It addresses a greener world in terms of how you become more efficient. I just got off a conference call with some leaders in terms of deploying energy management in complete ecosystems and how you optimize at a very granular level as well as a coarser level to really optimize energy usage and make the planet greener. And then we touched on the private data protection. No one is ever going to be comfortable. They will always be worried about their data. They should be worried about the data. Security will not be a one-time, you can trust it. It is an ongoing battle, and you need to continuously put mitigation actions to enhance security, look at new threats that you've thought of and didn't think of in terms of these attack surfaces, and build trust by building an ongoing, growing capability around security in all aspects of this edge to cloud confidential computing world that we're evolving into.
Yeah, well, I think what people need to realize is this stuff's coming whether you know it or not. All of the major cloud providers are rolling this stuff out. It is going into edge devices. It's going to be there. So I want to be in a world where you're designing your system and you say, I care particularly about this bit. Let's say, yes, I need this to be more secure and I need to know what my trust metrics are. So you tick it and that bit is just deployed in a more secure way. And as we go along, it'll be not which ones should I make more secure, it's just which ones I don't care about, because it's going to be easier and easier to put more and more of this stuff just and make it more secure. I think we're going to move there. It's going to take a while. It's going to take some process changes, lots of engineering as well, lots of work for me and everyone who's involved with engineering to be doing, but that's where I want to be going, where it becomes transparent because it's everywhere. And it's just the obvious right thing to do. It's not a tick that box, is are you sure you want to untick it? That sort of world.
That's a great point. I mean, I want to thank all of you for being here. I certainly am looking forward to living in the world that Mike presented, where security is just a tick box and it's transparent, and I don't want to untick it. I cannot wait for that day. So thank you all, and I hope that you have a lovely day. Thanks to all our viewers.